This lesson, we will be discussing matter and several concepts that surrounds matter. So at the end of this lesson, you should be able to clearly define what matter is. Should be able to state some of the basic characteristics of matter. Should be able to describe the three major classes, three major forms or states of matter. Also, you should be able to describe particles arrangement and movement in solid, liquids, and gases. You should be able to explain the various changes that we can subject matter to, from melting, freezing, evaporating, condensation, and sublimation. You should be able to classify matter into elements, compounds, and mixture. You should be able to make comparisons between solids, liquids, and gases. Okay, you should be able to distinguish clearly between elements, compounds, mixtures with examples. You should be able to compare mixtures and compounds using table. That is, give the composition, properties, and separation and formation. You should be able to explain the types of mixture, homogeneous mixture and heterogeneous mixture. You should be able to state the differences between physical and chemical changes with examples. Also, you should be able to differentiate between physical and chemical changes with examples. Also, you should be able to identify the various chemical changes. So this will be the objective for this lesson. So let's get right to it. First, let's ask ourselves, what is matter? What is the meaning of matter? Okay, so matter is anything that has mass and occupies space. Okay, take note, we say that has mass. Okay, any substance that, or anything at all that has mass and occupies space can be regarded as matter. And the three basic forms of matter or states of matter are solids, liquids, and gases. Now, what are the general properties of matter? So matters are made up of tiny particles. Okay, they are made up of tiny particles. Sometimes we call these tiny particles atoms. This we say the building blocks of matter are atoms. These atoms are what comes together to form matter. And this matter, these particles are continually or they are constantly in motion. Okay, you need to know that. And of course, as we have said, matter possesses mass and it occupies space. Okay, and it also exists between these particles that made up this matter, there exists forces of attractions or repulsion, depending. Okay, so generally we could say there are some forces of attraction, intermolecular forces that exist between these particles. Sometimes the forces of attraction can be strong, sometimes it can be weak. Okay, and this matter or these particles, the matter could expand upon heated and it could also contract upon cooling. Okay, meaning it responds to changes in temperature. It responds to changes in temperature. Now let's look at the various states of matter and their properties. Try to make comparisons between the three states of matter that we are discussing, which is solid, liquid, and gas. We can have other states, but majorly we are focusing on solid, liquid, and gases. Now, looking at shapes, solid has a fixed shape, okay, because of the way the particles are arranged. It gives a fixed shape to solid. Unlike liquid and gases, they do not have any fixed shape. Okay, they do not have any fixed shape. Usually, they take the shape of whichever container you kept them in. Okay, if you have a rectangular bucket and you pour water inside it, for example, it takes the shape of that bucket. If you pour that same water into a cylindrical tank, the water also assumes the shape of a cylindrical tank. So fixed volume, both solid and liquid have fixed volumes. Okay, they have fixed volumes because of the forces of attraction between them is strong. So they retain their volume, they maintain their volume. Unlike gases that the forces of attraction between its molecule is weak as compared to solid and gases and solid and liquid. Hence, the particles can easily move apart, hence occupying whichever container they are placed in. So you say volume of gases are not fixed. The particle arrangement, okay, the particle arrangement, as we have said, the particle arrangement in solids are closely packed. Okay, for example, let's look at this, the diagram on the next page. Looking at this diagram on the next page now, we can see that the particle arrangement in solids are fixed. Okay, that in liquid are not. Okay, the particles are still continually moving, even though all of them are continually, but the motion in liquids, the particles, motion within the particles of solids is rigid, while that in liquid and gases are much more faster. Okay, even though that of gases is faster than that of liquid. So in terms of looking at their arrangement, the particle arrangement in solids are closely packed. That of liquid is moderately packed, and that of gases are widely spaced and disordered. So the intermolecular forces, as I've said, in solids are stronger, and it is weakest in what? In gases. The one for liquid is moderate. Compressibility, solids are regarded as not compressible. Okay, so liquid is slightly compressible. Sometimes we could say it is even the compressibility is quite negligible, very small. Okay, unlike gases that are what? Highly compressible. That is, the particles can be forced together and they can assume either liquid state or gaseous or solid state, as the case may be. Okay, let's look at some other properties. Some other properties of matter also include the vibration within the movement within the particles. So the vibration in solids occurs. The particles vibrate in fixed positions. Okay, unlike that of liquid that we have looked at, there is the particles of liquid slightly slides over one another, so giving it that fluidity, ability to flow. Unlike gases, where the particles are very free. Okay, they are very free and they can rapidly travel in all directions, colliding with themselves and the wall of whichever container is holding them. Also talking about density, gases has the lowest density of all, and the density in solids is highest. Okay, and looking at energies of particles, gases has the highest energy. That's why the particles can continually be in motion. Okay, because of the high energy, and the energy of particles is lowest in solid. That's why they are rigid and they stay or vibrate in fixed positions. Diffusion rate, of course, gases, because of that high energy, they diffuse the fastest, while solids diffuses the lowest. And container dependence, okay, solid is independent of container, while gases are completely dependent on the container that contains them. Okay, that's why they could assume the volume of their container. Unlike solid, they can maintain whichever container, they can maintain their particle arrangement, whichever container you place them. And examples of solids, we have ice is an example of a solid, metal, wood, plastics, okay, in at room temperature. So while examples of liquids, we have water, oil, petrol, and so on. Several examples, there are uncountable examples. And oxygen is an example of gas, nitrogen, carbon dioxide, and so on. Your cooking gas, they are the chlorine gas, they are all examples of gases. Now, let's look at the kinetic theory of matter. Okay? Kinetic theory of matter talks about what matter are made of and how they move and how do they change in speed with respect to temperature, and also talks about the forces of attraction that exist between them. So when asked about kinetic theory, first you have to identify that all matters are made up of tiny particles. So these tiny particles are called atoms. And these particles move randomly. They are continually moving. Okay? And also, it is important to identify that the speed of these particles increases with temperature. That is, when temperature is elevated, then this particle tends to move faster. Okay? And the intermolecular force of attraction varies across states. Intermolecular force of attraction in solid is highest, as we have discussed, and it is lowest in gases. Okay? So, and that's point number 3 that we said. When temperature increases, for example, when you increase the temperature of solid, for example, let's say ice block, for example, we have ice inside a container, and you heat up this ice, there's chances the intermolecular force of attraction here can break, that will further space the particles arrangement. Okay? And if this heat is also maintained, the particles can go farther away from themselves, meaning that, so we can say that the more, as the temperature is increasing, it breaks the intermolecular forces of attraction. Hence, the speed of the particles increase proportionately. So that is that about kinetic theory. That's just a brief discussion around kinetic theory. Now, another important point under matter that we need to discuss is the change of states. Okay? As we have said, it is possible that substance can change states from solid to liquid. And further, liquid can also change to gases. Okay, so within the 3 states of matter, we can have different changes. These changes are summarized in this diagram you are looking at. Okay, we have when liquid, when solid, let's start from solid. When solid is heated, okay, let's say you subject a solid to elevated temperature, what happens? It melts and it turns to liquid. Okay, the reverse of that reaction, of that process, is freezing. So the process whereby solid changes to liquid is called melting, while the process whereby liquid changes to solid is called freezing. Okay, similarly, we could have liquid turning into gas. That process is evaporation, or as in the case, could say vaporization. So liquid turning to gas, evaporation, while gases turning back into liquid follows a process called condensation. So condensation is a process whereby gas turns into what? Directly into liquid. Okay, now we could also have a case where some solids can turn directly into gas without passing through a liquid state. That process is called sublimation. Okay, it is have to be emphasized that that point without passing through the liquid state is very important, because it is possible for us to heat up ice continuously, like solid continuously, and the solid changes to liquid first before changing to gas. So that transformation could happen in this path. If it happens in this path, that means it's 2 processes that is happening, melting and evaporation. But in a situation where there are some substances that they can get transformed directly from their solid state to the gaseous state, directly without passing through the liquid state, that process is referred to as sublimation. And the reverse of that is deposition. A typical example is we have, there's a substance called camphor. So this camphor, usually whitish in color. Okay, it is commonly used in wardrobes. So people put it inside their wardrobes to keep cockroaches away from clothes. So this can form, okay? After some time, you see that it will just continue to reduce in size. So it is not melting because you are not going to see any sign of it melting. It is subliming, subliming. So after some time, you just see that it's getting smaller and smaller. So it is the particles of the camphor within the solid breaks away and turns directly into gas. Okay, and wherever that gas moves to, that gaseous movement, it eventually gets deposited on clothes or within the wall of the wardrobe. Okay, so that process whereby that gaseous camphor eventually get deposited back as solids within the wardrobe. So that is the process of sublimation and deposition. Process whereby solid changes directly to gas, sublimation, while process it changes from solid directly to liquid to solid is referred to as deposition. Now let's move on. Now it is important at this point for us to discuss the concept of physical and chemical change. When we say physical change, what do we mean? And when we say chemical change, what do we mean? Okay, physical change involves majorly change of state. Majorly, it usually involves change of state. When, for example, the states we just discussed now, okay, no new substance is formed. For example, when you bring out some ice cubes from the fridge or from the freezer and you kept it on the table, okay, after some time you see that the ice melts and turns into water. Okay, but the fact still remains that the ice is water, the liquid is also water. So there's no new substance is formed. Unlike in chemical change, there's new substance are always are formed. Example is when you burn wood, okay, you see that when you set wood on fire, after some time you are going to have ashes. Okay, new substance, which is a new substance, very much different from wood. Okay, so usually, as we have looked at in the change of states, generally physical changes are usually reversible. That is, you can move forward, you can also move backward. The reversible reaction is a reaction that can proceed in two directions. The product and the reactant turns into product can go back. That's what we call reversible reaction. So generally, physical changes tend to be reversible. That is, water, for example, water can be frozen and it turns to ice. Ice can melt and it goes back to water. That kind of process is said to be a reversible process. So usually chemical reactions or chemical change are usually irreversible, but not entirely. There are some chemical reactions that can also be reversible. But generally speaking, the majority of chemical reactions tend to be one directional. Okay, affects physical properties only. Yes, physical change affects only the physical property of that substance. It could be solid before it now becomes liquid. Okay, whereas chemical change affects the chemical composition. Okay, a particular reaction could have the substance originally, the reactant completely transforms into a different new substance. So the chemical composition of the reactant is very much different from the chemical composition of the product. Okay, in fact, that's why it is called chemical change. Okay, so energy change is usually small. That is, energy change involved when we are talking about physical change is usually small as compared to chemical change, that the energy could be significantly higher than the one we observed in physical change. Examples of chemical change is we could have melting. Physical change, we have melting, dissolving sugar in water, even boiling water. They are all physical change. Okay. While example of chemical change, we have rusting. When you have iron, and after some time you see that the iron, you are seeing some brownish appearance on the iron, so which is completely changing the iron from iron 2 to iron 3. So like all this kind of change is a chemical change. Okay, it's a chemical change. Burning, as we have explained earlier, is also a chemical change. Digestion is a chemical change. Fermentation, to mention a few. So these are some of the examples of physical and chemical change. Now, let's quickly look at these three points. elements, compounds, and mixture. Okay? Now, what's an element? It's a pure substance consisting of only one type of atom. Okay? An element basically contains just one type of atom. Okay? So, an element is like a packet of atom. Okay? Like, sorry, oxygen here is an element. Iron here is an element. Copper is an element. Okay? Sodium, Na, is an element. So these are elements that contains atoms of their own element. Only one type of atom is present in them. For example, iron, for example. Okay? Like this, when we say iron, we mean iron as an element means it contains several atoms of iron. Just like saying when you have a house, or let me say a brick house, a house that is completely built with bricks. So what made up the building block of that house is bricks of the same type. Okay, so the entire house is like the element, while the bricks are what? Are the atoms. So element is like a packet. It's like a packet of atom containing just the same atom. Okay, the same atom. Iron eventually forms iron as an what? As an element. Good. While a compound is a pure substance. Okay, a pure substance formed when two or more elements combine chemically. That's what we refer to as what? As a compound, and it usually involves fixed ratio or fixed proportion. Okay, that's why compounds usually have chemical formula, because the combination is in a particular fixed proportion. So hydrogen combines with oxygen in the ratio 2:1 to form water. Sodium combines with chlorine in the ratio 1:1 to form sodium chloride. Okay, carbon dioxide combines with carbon and oxygen in the ratio 1:2 to form CO2. So this is compounds, chemical combination of elements in a specific what? In a specific ratio. Now, how about mixtures? Now, when we talk about mixtures, mixture is a physical combination of two or more substances that are not chemically combined. They are not chemically combined. Okay? So it contains two or more constituents that are not chemically combined. They are physically combined, and hence they can be separated by physical means. Unlike compounds, the elements cannot be separated by physical means. Okay, we're going to look at difference in a minute. So examples of mixtures are air, sand and salt. If you mix sand and salt together, it is a mixture. Okay, air is a mixture because air contains oxygen, it contains nitrogen, it contains carbon 4 oxide, it contains noble gases, and it also contains water vapor. Okay, so all of them combining together. Okay, so but they are mixtures, meaning that they can be separated by physical means. Because that's why you cannot say air has a chemical formula. Air doesn't have a chemical formula because it's a mixture of compounds. So one major difference is compounds usually have a chemical formula. Mixture doesn't necessarily have any chemical formula as they exist in that mixture, even though each component might have their own chemical formula. But the mixture itself doesn't have a new chemical formula. Now let's look at some differences between compounds and mixtures. Okay, compounds are formed by chemical combination of elements. We have said that, while mixtures are physical combination of elements. Okay, compounds are always in fixed ratios. Components in compounds are always in fixed ratios, while components may not. They can be in any proportion you want them. Okay, you could mix 1 cup of sugar and 3 cups of water, if you like. Okay, you could also reverse the case: 3 cups of sugar, 1 cup of water. You have a mixture. So now the next point: components loses their individual properties. Yes, when an element combines chemically with another element, the behavior of that element within the new substance is different from its original property before the combination. Unlike in mixtures, each of the elements still may retain their original properties. Now, separation of these elements definitely requires a chemical method, whereas for mixtures, it requires only physical methods to separate them. And we have sort of said it, compounds generally have definite formula. Mixture do not have definite formula. Okay, energy changes occurs during formation. No major energy changes occur when mixing. Okay, no significant energy changes occur when mixing. Okay, examples of mixtures are compounds are water is a compound, but that's H2O. Ammonia is a compound, NH3, and sodium chloride is a compound, that's NaCl. Okay, these are examples of compounds. While examples of mixture, air is a mixture, salt water is a mixture containing salt and water, and sand and iron filings is also a mixture containing sand and iron filings. Okay, so these are some basic examples around mixture. Now, we have explained this. Just to look a little bit deeper into mixtures and compounds, just to shed more light to that. As we have said, salt water contains is a mixture that is salt and water, okay, and it can be separated by just if you vaporize or evaporate the water, you can get back your salt, okay. So the combination within of the salt and water is a physical combination, not a chemical combination or chemical reaction. While air is a mixture also, okay, and it involves nitrogen, oxygen, and so on, and it is physically combined. Iron and sulfur, for example, is also a mixture. Iron can be removed using magnets. And you can just, if it's a powdery mixture, you could just roll or turn a magnet within the powdery mixture, and all the iron filings will be attracted by magnet, while sulfur will not. Okay, separation technique is a whole topic on its own, which we will not be discussing in this lesson. So, water is a compound. Of course, hydrogen and oxygen are combined in a specific ratio, and carbon dioxide is also a compound. Carbon and oxygen are combined in a specific ratio, and it cannot be separated by physical means. So it's a compound. Iron 2 sulfide. Iron 2 sulfide is a compound, which is a chemical combination between iron and sulfur. Okay, formed by heating iron and sulfur. Properties differs from element. That is, the properties of iron and properties of sulfur are when they are separated as iron and sulfur is different when there is a chemical combination between iron and sulfur. Iron 2 sulfide have different properties as compared to iron and sulfur separately. So that is a further explanation on mixtures and compounds. Now, let's take a little bit deep diving into mixtures. Mixtures can be homogeneous, and mixtures can also be heterogeneous. So when do we say a mixture is homogeneous, and when do we say a mixture is heterogeneous? So a mixture is homogeneous when it contains only one type of substance within the mixture. That is, only when the composition of the mixture is completely uniform. Yes, that's what we call homogeneous mixture. When we have a uniform composition throughout the solution, then we say it is a what? It is a mixture. Okay, but in a case where we have a non-uniform composition, then we say the solution is what? Is not homogeneous. That is, it's heterogeneous. The word homo means the same. The word hetero means different. So components are evenly distributed. Yes, components are evenly distributed in homogeneous mixtures, whereas they are not evenly are distributed in heterogeneous mixtures. So there's always a barrier. You cannot see, for example, in homogeneous mixture, you cannot see the different parts of the mixtures because they are uniform. There's uniformity. Unlike in heterogeneous mixtures, you could see the barrier. For example, when you pour, if you try to mix kerosene and water now, you'll see that you have a barrier that separates the two mixtures that you can see with your naked eyes, okay? Because it's an heterogeneous mixture. Whereas when you try to dissolve sodium chloride in water, you see that you have a complete dissolution, and without any difference in composition observed. You will not be able to observe any difference in composition. So that mixture is said to be what? Homogeneous. So only one visible phase, yes, only one visible phase. But in heterogeneous mixture, you can have more than one visible phases can be observed. Now, generally, though homogeneous mixtures can also be separated, but they are much more difficult to separate as compared to heterogeneous mixture. So difficult to separate components by physical means is quite difficult as compared to. Note the point, it is not that it cannot be separated. It can be separated. I mean homogeneous mixtures. Whereas just make a comparison between the two. Homogeneous mixtures is much more difficult to separate as compared to heterogeneous mixtures. Properties are the same throughout the mixture. Yes, properties are the same throughout the mixtures for homogeneous, while properties vary from one part of the mixture to another in heterogeneous mixture. Examples of homogeneous mixture is salt solution, sugar solution, air, and brass. Okay, brass is a mixture of zinc and copper. That's what we call brass. Okay, a mixture of zinc and copper is an alloy. Okay, just like we have bronze. Okay, bronze is a mixture of copper and tin. Copper and tin is what gives bronze, while brass is a mixture of zinc and copper. These are solid mixtures. Okay, then examples of heterogeneous mixtures when you mix salt and water or oil and water. Okay, or even granite. Okay, then you mix. These are examples of what? They are examples of heterogeneous mixtures and homogeneous mixtures. Okay, now just to look at a few of the separation techniques that are used to separate mixtures. Okay, as I said, separation techniques is a whole topic on its own. If you want me to explain it much more in details, just let me know in the comment and I will do just that. Okay, so separation techniques, just look at a few of separation techniques. We have filtration. Filtration is generally used to separate insoluble solids from liquids. For example, if you have an insoluble solid within a liquid, it can be separated. It can be separated using filtration. Then we have evaporation, dissolved solid from solution. Sometimes if you have a dissolved solid, you can vaporize or evaporate the liquids and you have your solid. Distillation is commonly used to separate liquids with different boiling points. Okay, it could be close or it will be depending. It's generally used to separate miscible liquids. Okay, to separate miscible liquids with different boiling point. And while fractional distillation is also used to separate miscible liquids. Chromatography is used to separate. Example of substance that can be separated with chromatography is separation of colors. Substances that travel at different speed within a mixture. So chromatography can be used to separate that. We have magnetization. When one of the components is a magnetic material, then we could use magnetization to remove that magnetic material and we further subject the rest to suitable separation technique. And decantation, in a case where we have two substances or two or more substances that one can definitely sediment, Okay, while the other one floats. In that case, we can decant off the one that floats, and we have the one that sediment. So we're going to stop here. So this is like a full revision on the basic introduction to matter. So if there's any other specific topic you want me to explain, I have notes in virtually all topics. So if there's a specific topic you want me to explain, please don't just drop it in the comment section, and I will do just that. Also, so that we can also be aware whenever I drop a new video, don't forget to subscribe and click the notification bell so that you'll be alerted once I release a new video explaining concepts in chemistry, physics, and mathematics majorly. So thank you for listening. So see you in the next class.